I want to say what goes wrong when you try to do this for Simon's problem. I don't think anybody has ever written this up, and it's neat. So, Simon's problem. Try to turn into communication complexity. And I am running out of chalk. Okay. So Alice has function F mapping. Well, F maps, I guess, log n bits into now, presenting this to you, I may discover that I'm wrong about this, but let's try to do this for Simon's problem anyway. So Alice has F mapping log n bits into log n bits, and Bob has G mapping log n bits into log n bits. And we know, F of x plus G of x plus F of x plus c plus G of x plus c is, I want to say it's 0. Because remember, Simon's problem, F of x was equal to F of x plus c. So here what we're doing is we're taking F of x plus G of x instead of F of x, and F of x plus c and plus G of x plus c instead of F of x plus c. And when you take the exclusive OR of all 4 of these things, you want to get 0. So here I want to say Alice can compute. So what can Alice compute? Alice can compute oracle x b2 x f of x plus f of plus g of x plus b using one log n bit message actually it's 2 log n messages because she sends something to Bob and Bob sends it back. So Alice sends Bob x b. Bob computes x b plus g of x. So he does this just the same way he did for the Deutsch-Jozsa algorithm and for Grover's algorithm, and sends it back to Alice. Alice computes x b plus g of x plus f of x. Okay. So Alice can do Grover's algorithm. Or Alice can do Simon's algorithm if she has Simon's oracle. But I think I want to remind you what Simon's algorithm does. I want to remind you some of the steps of Simon's algorithm. So Simon's algorithm, Alice and Bob, well, Alice, I mean, really, there's only one person running Simon's algorithm. So Simon's algorithm, we start with superposition x, 0 to n minus 1, 1 over root n 0 to 1 over root n I equals 0 to n minus 1 x f of x to 1 over n summation I summation j minus 1 to the x dot y y f of x. These are, yes, this summation index is x, x, and x and y. And we only see y if y is perpendicular to c. And the reason for that is, well, there's exactly two y's with the same f of x. And one of them is y, and the other was y plus c. And if, no, there's only two x's with the same f of x. One is x, and the other is x plus c. And if y is not perpendicular to c, minus 1 to the x dot y plus minus 1 to the x plus c dot y equals 0. So we only see y's with y perpendicular to c.